All right, welcome. So this is going to be our first video for Calculus 3 and Engineering Calculus 3. So no effective difference between the two courses. Even before pandemia, they were the same course, okay? So we're going to start with 9.1 parametric equations, okay? So parametric equations, just in not so many words, or it's just a fancy way of saying, hey, we've got multiple directions that we're looking at with one parameter. Okay, so most of you have probably seen parametric equations before. A certain example or a very specific example is one you often see in a Physics 1 class. So let's go ahead and discuss that one. So let's say you have an object I don't like writing cursive on these. An object is fired or launched from a height of 10 meters with an initial velocity of 5 meters per second, okay, at an angle of 30 degrees above the horizontal. Okay, how far downrange does it travel? Okay, all right, so the first thing is we're going to do is we're going to describe this situation by parametric equations. So you guys are going to get tired of hearing me say this. I get tired of saying it, but we're going to draw a picture. And let me change that picture color to, there we go. Okay, so it's going to be 10 meters above the horizontal. Okay, that's 10 meters. All right. Fired at a velocity of 5 meters per second. Let's call that V0. Okay. At an angle, theta is 30 degrees. Okay. Let's make that a little bit bigger, easier for you guys to see. Okay, so what's going to happen? This thing's going to go, hit its max, and come back down. Okay, so let's write our parametric equations. Okay, so our parametric equations have, for x of t, okay, that's going to be our 5 meters per second times, now the x component of motion is just going to be the cosine of that angle. So cosine of theta, which is, theta is 30 times t. Okay. Our y of t, okay, this is going to be 10. That's the initial velocity, or the initial height, plus 5 sine theta times t. Okay, no reason why, this and this are the same. I know I have the parentheses around one. It's not going to matter. The real reason I have the parentheses here is to know that t is not being, I'm not taking the cosine with the t inside, or the sine with the t inside. Okay, minus, since g here, this is, we're in meters per second, so our g is 9.8 meters per second squared. Okay, So our g here is going to be minus, or it's 1/2 of that, 4.9 t squared. Okay, write that a little better. Okay, now we need to find when does this thing hit the ground, right? So when does the object hit the ground? That means we need to solve y of t equals 0. Or 10 minus 5/2 t minus 4.9 t squared equals 0. Right? Because sine of 30 is 1/2. Okay? So when we solve this using our quadratic equation, okay, so t is negative 5/2 plus or minus square root of 25 over 4 minus 4 times negative 4.9 times 10 all over 2 times negative 4.9. When I do that, I get two numbers, negative 1.14 and 1.706 seconds. Okay, now this one is out. Okay, what does that negative time represent? That negative time represents, well, if we extend this parabola back in time over here. Okay, and so now how far does it go downrange? It's going to be 5 times cosine of 30 degrees times 1.706. And that's going to be in meters. Okay? All right. That's it for this first video. What I'm normally going to do is I will split it up by page. That'll make it easier for you to find stuff. Okay? So if you want to look and you see this problem, you know it'll be the first video of 9.1. Okay? All right, I'll see you all in the next video.